usual, one question akan ada anak-anak lah. So A, B, C. What was that? Dua orang masuk ke? Okay, tak ada. Okay, so you have 4 main questions. The first question will be chapter 15, second question chapter 16, 17 and 18. So boleh agak-agak lah. So the first question, you need to focus everything that you know about chapter 15 and so on. And then for each question, there will be A, B, C, D, and your working steps will give you marks. Before this, you were doing in website where only your final answer and sometimes your jalan kerja will give you the marks, right? But here, when you're doing face-to-face exam, your jalan kerja is everything. Your final answer must include unit, must. If not, you are not going to get the
Kalau
job.
jalan kerja tak include unit,
Tak ada rasanya. Setiap bila kita buat fizik tak ada unit. Itu soalannya. So your answer must include unit. And remember, everything should be in SI units unless that equation boleh pakai other units. So you need to be aware what equation does not use the SI unit. Yang lain memang confirm pakai SI units. Okay, so here we have the term define. Define is intended literally only formal statement. Formal statement meaning to say just the definition as in a sentence. Contohnya, the first law of thermodynamics is, I don't know, kejap. I don't know. So I don't remember. Okay. So it's in your book lah, the definition. I wrote it down. I'm sure because I was the one who did the chapter. So there is a sentence that you need to memorize. That is your definition. If you decide to give me a sentence as your answer, if not, you can give me an equation. However, if you give me an equation, you need to define all the symbols. Okay. Let me show you how to do that. So here, let's say the first law, tak boleh ke? File, new presentation. Habis tak boleh. Sekejap. Let me try here. What is this day? It's not cooperating. Okay, so let's say, let's go for a, apa ni? Terjadi juga. Okay, bismillahirrahmanirrahim. Saya doa siap-siap. No. Okay, today is not so lucky. Jangan kurang. Okay, so let's say tengok tu. Is it because I have so many presentations going on? Kejap. Oh, ni jap. Okay. I don't know how to do this one. Google Meet ke ni yang buat masalah ni? I don't know what it is. Bismillahirrahmanirrahim. Okay. Kenapa? So define, okay. Boleh. Okay, so what the heck? Okay. I think I need to restart my computer. But first, let's go over this one first. Okay, so let's say define, right? Define, let's go for easy definition. Define resistance. Yes, define resistance. So resistance R is equal to the rate of charge flowing, right? So it was Q over T, if I'm not mistaken. So I can give you a sentence. Resistance is the rate of flow of charges. Okay, so rate already means time, right? So rate of flow of charges. So that definition is complete. But if you decide to give me an equation, which is R, you write down R equals to Q over T. Contoh. You cannot give me the equation like that. I will consider that you don't understand anything because I don't know if you know what R means. I don't know if you know what Q means. I don't know if you know what T means. So what you need to do is R is resistance, Q is the number of charges, T is time. You need to define all the symbols that is in your equation. So this is the tricky part. Usually students will write the equation but not define the symbol. So that is where they lose marks. And usually for defined questions, it is 1 mark. Okay, tapi 1 mark out of 30 is quite a lot lah. Or 35, I don't remember the full marks. So 1 out of 20 or 1 out of 30, it's a lot. So definition question, walaupun satu markah aja, please take it seriously because it's supposed to help you. It's supposed to be the easiest question in the test. Okay, so define, either you can give me a complete sentence or you can give me the equation, but you need to define all the symbols. Okay, next one. What is meant by normally implies that a definition should be given. I don't think we're going to use this one. Okay, explain may imply reasoning. So I think you know this already. Explain. Yang paling penting kat sini define lah. Define, you will see this a lot. And then list down. List down will always mean more than one. So requires a few points with no elaboration. Contohnya, can you list down how contohnya list down apa? Can you list down the thermodynamic processes in gas? Contohnya isobaric. So the first one is isobaric, isothermal, isovolumetric, and adiabatic, right? So the list always requires more than one. So if they ask you, okay, list down the thermal processes, so you list down all that you have. Sometimes they tell you list 2 or list 3, so you follow the instruction. Okay, so describe requires students to state in words using diagrams where appropriate. So if they ask you to describe, do not give equations. Okay, describe means gambarkan. So gambar usually comes with words or diagrams. So if you feel like your sentence is not enough to describe a law or a definition, or a law or like a flow diagram, contohnya macam heat engine. So let's say they ask you describe how a heat engine works. So you want to describe the heat engine but you feel like you need the diagram. You can have the diagram but you need to explain what the diagram is. Tak kasih diagram je tapi suruh orang macam faham lah sendiri. Tak boleh. You have the diagram, you explain the diagram. Okay. So this is when they ask you for describe in the test, in the question. Okay, so what we have covered so far: define, list, explain, describe. Okay, what is meant by ni tak ada. And then discuss, our test does not cover this one, tak ada discuss. And then suggest, yes, suggest boleh. Suggest contohnya, how do you improve, macam nak cakap, what is required to increase the thermal efficiency of a heat engine? How do you increase the efficiency of a capacitor? Suggest 2 ways. Contohnya macam tu kan. So suggesting on how to improve a component such as resistor or such as a battery have a lower internal resistance, right? Remember, our battery is composed of EMF and internal resistance. So if you want a better battery, the internal resistance should be smaller, right? Okay, so suggesting ni, it comes with knowledge lah, jangan main bantai je. And then calculate, you know this already. Of course, use your math. And then measure tak ada, this is for your labs. What else? Sketch, yes, sketch is quite famous. Sketch applies to graph work. Untuk test yang face to face memang boleh tanya lah. Okay, so let's say they will ask you sketch. So they give you a situation, gas starts from point A to point B. Point A is at pressure 1 atm, temperature of 30 degrees. Point B is pressure of 2 atm. Draw the graph. So that is possible. Okay, so that is when they ask you to sketch. Okay, other than that, I think that's it. What else do I need to tell you about the exam? 4 questions. The terms, The marks for each question, there will be around 7 to 8 marks. 7 to 8 marks. So 7 to 8 marks. So 8 times 4 is 36. 8 times 4 is 32. 32. So I think around 7 to 8 per question. So ada soalan yang 7 markah, ada soalan yang 8 markah. Okay? What else? What else about the test? Okay, I think that's it. So now saya nak cuba restart komputer and see if I can start drawing. Okay, kejap korang. I'll be back. Restart. Yes. Okay. Is it now? Your entire screen. Okay. So now I hope I can open this. Yay! Thank God. Okay, is it still recording? Okay, it's still recording. So insert new slide. Okay, so let's write down what we have talked about. Jangan macam ni, please. Okay, so we talked about the exam. 4 questions. This is so small. Them 4 questions. Dan ada anak-anak lah. Chapter 15 to 18. And then each question has 7 or 8 marks. And you need to be aware of the different terms that they use, such as define. What does define mean? You can give me a complete sentence or equation, but please define the symbols. Okay, so let's say I need a good equation. Work done is equal to, let's use PV equals to nRT. So PV equals to nRT. You cannot give me this equation and expect a full mark. So what is P? P is pressure volume. You can do the arrows, doesn't matter. Or you can say where P is pressure, V is volume, number of moles. What is R? This is the universal gas constant. And what is T? This is temperature in Kelvin. Remember, chapter 15, everything is in Kelvin. Okay, so that is your definition punya question. Sometimes they will ask you to list. It means more than one. Jangan kasih satu je. Kalau tak ada pun bantai lah. Ni exam kan. Just try your best to get to optimize your marks. And then list, describe, diagram, and explain your diagram. Boleh. And then there is also define, list, describe, explain, suggest. Okay, suggest how to improve or how to decrease, how to improve or kita nak buat make it worse kan, tapi kadang-kadang ditanya juga how to decrease performance of something, of a component. Sebab teori kan, so it can ask you how to make something go bad. So explain, suggest, describe, list, and also define. So these are the terms that you need to be aware of, that I'm aware of lah as your lecturer. So subjek lain saya tak tahulah. Okay, so this is that. And then question 7 to 8. Okay, let's go on to the questions. Okay, so revision question number 1, which is on chapter 15. Before that, does anyone have any questions for me about the test before we start discussing the answers? Let me see. Ada tak soalan?
Doctor,
Yep.
is it true that the exam paper will not give us any formula at all?
Betul. Okay, I forgot to mention that. No formulas will be given, only constants. Oh my god, yeah, forgot that. No formula is given. That's why they can ask you the definition. Because if formula is given, then soalan macam ni pointless lah. Dapat markah free kan. Tak boleh lah. So no formula is given, which means that you need to memorize all the formulas. Constants will be given. But it's best if you can memorize the constants as well. But check back balik lah, sebab dia akan kasih kat first page tu, dia akan kasih constants. But untuk laju, I suggest to memorize kalau boleh. Okay, kalau tak boleh, just rely on the table. Okay, no formula, no formula. I hope everyone is aware of this. Apa lagi soalan about the test? Ada tak? Kok saya tertinggal ke? Anything else? Okay, no questions. Okay. So moving on to the first question. So the first question is about a cylinder of volume 0.335 ke? Korang punya soalan randomize ke? I think I did not randomize it. Sekejap. Kalau tak, jawapan saya lain lah dengan korang.
Dalam kira je penting.
Jangan kira je penting, betul. Tapi saya nak check juga jawapan betul ke tak ni. Nombor 3, tengok soalan dia jap. Nombor 3, soalan dia 393.9 jawapan. 393.9.
Doktor tu soalan 2.
Oh sorry, betul. Thank you. 393.9. Nombor 3, Haikal 1.35. Oh no, I don't have the same questions as you guys. Okay, never mind. Yeah, betul lah cakap Sofia. Jangan kira je penting. Okay, so a cylinder of volume 0.35 contains 11 mole of neon gas at 20.2. Assume neon behaves as an ideal gas. Of course, chapter 15 semua kita assume ideal lah. Okay, so this is volume. And this is your N. This is your V. Your V is also already in SI unit. This is the right unit as well, mole. But this guy is in Celsius, so it should be in Kelvin. So what did Sofara do? V correct, and then she converted the Celsius to Kelvin. And R is the universal gas constant. I should use red because I'm the teacher here. Okay, red. Okay, so she used, what is the pressure of the gas? So she used PV equals to nRT, betul? P nRT over V, so 11, 8.314, 293.2 and 0.35. Okay, so all the substitution is correct. Okay, one thing I need to tell you is this part of the answer is giving you 1 mark. Correct substitution 1 mark. Final answer 1 mark. Boleh. That is how we grade the test. So equation, substitution into the equation yang betul, substitution yang betul, substitution yang salah tak dapat markah. Jawapan yang betul with units. That is how you get the full mark. Okay? Penting this part, substitution, equation, substitution, final answer with units. Okay. Find the internal energy of the gas, U. Internal energy is always about U. U is related to 3/2 nRT for monoatomic. Monatomic. Kalau diatomic, it should be U equals to 5/2 nRT. Diatom. Okay, you guys know what I'm talking about. So it's U equals to 5/2 nRT. Now, if you are trying to find the change in internal energy, it should be delta U. Your delta should be balanced on the other side as well. So here, your R cannot change, your N cannot change, the mole does not ever change. The only thing that can change here is your temperature. So 5/2 nR delta T, or delta U equals to 5/2 P delta V, or delta U 5/2 delta P V. Boleh. Remember, PV equals to nRT. Kalau nRT ada 5/2, PV pun ada 5/2. Kalau nRT ada 3/2, PV pun ada 3/2. But this is only for U. Untuk cari internal energy. So U equals to 5/2 nRT ataupun 5/2 PV. Untuk cari pressure of gas, ideal gas, do not add the 3/2 or 5/2. It's not correct. This is the equation for ideal gas. Bukan untuk cari internal energy. This is to find the states of ideal gas. So if you want to find the pressure, you want to find the volume, you want to find the temperature of an ideal gas, this is the equation that you should use. However, if they are asking about internal energy, U is the equation to use. So U equals to 5/2 nRT or 5/2 PV, or 3/2 nRT or 3/2 PV. If they have the delta, which is the change in internal energy, the right hand side of the equation should also have delta. Kena ada, wajib. Okay, this is math, so that is how it is. Okay, so B 3/2 nRT, this is a monatomic. Neon monatomic korang? Is neon monatomic? Is it? It's N2 kan? H2.
Yes. Yes, Doctor.
Okay.
It's N.
It's what? It's just N?
NE.
It's NE. NE. So H2 baru jadi diatomic. Sekali je N2. Okay, saya tak pandai chemistry. So Ne, because it is a monatomic, it exists as a single atom. Correct tak? I hope I'm correct. So Ne So diatomic dia akan exist as pair. So O2. What else? Tak tahulah. Okay, so diatomic exists in pairs, monatomic exists as one. So if they tell you if it's a monatomic, use 3/2 for your ideal gas, for your internal energy. Kalau diatomic, pakai 5/2. Okay, moving on. C, suppose the gas expands at constant pressure to a volume of 1000 meter cube. So the expand constant pressure. P is constant. So we know that this is about an adiabatic process because adiabatic isobaric. P constant is isobaric. Suppose that the gas expands, meaning to say the volume changes. So there is a delta V going on to a volume of 1000 meter. Mula-mula tadi, the volume was this one, 0.35. Okay, so there is a change. How much work is done for the gas? So work done, we know this already, W equals to minus P delta V. This is for isobaric. This equation holds for isobaric process because pressure kena constant. Kalau pressure tak constant, this equation tak boleh pakai lah because P needs to be constant. So delta V, we know this. It is V final minus V initial. So what is V final? It is 1000, it's 1000. 1 meter cube minus 0.35. And pressure kita dah cari tadi 7661 Pascal. Okay, so pressure punya SI unit is in Pascal, not in ATM. So you need to convert it kalau dia orang kasih ATM. Okay, so remember your equation ni ada negative sign. I always forget to put the negative sign. So please do not be like me. Please have the negative sign, okay? So that is the right way to do it. Okay, so what is the temperature of the gas at the new volume? Okay, so here we already have the P, which is constant. We already have the T, it was given, which was 293.2. So T is 293.2 K. It's asking what is the temperature of the gas at the new volume. So the V initial was 0.35. The V final is 1. So when we are trying to find a new state, we always go back to this. Remember, state. We are trying to find the state, not the internal energy. Finding the state of a gas, we go back to this equation. Look at what we are trying to find. We are trying to find the new temperature. So the temperature is supposed to be changing lah. And V changes, T is supposed to change. So P and R is constant. So everything that is constant goes to the right. And R over P. V goes to this side, T goes to the other side. So V over T equals to a constant. So now you have V initial, T initial, V initial, T initial equals to V final, T final. Or here, so Farah did this by using V1, T1 equals to V2, T2. Boleh juga. Okay, so this is your V initial 0.35, 293.2. Your final V is 1, T is, you are trying to find T2 lah. Okay, so this is correct. This is the right way to do it. So I would give this answer 1 mark for the equation, the right equation. 1 mark correct substitution, 1 mark for correct answer with units. Okay. So senang je dapat markah sebenarnya. So okay, find the internal energy of the gas. So internal energy is always about U, not the state. Remember, state is PV equals to nRT. U is internal energy of the gas when its volume is 1 meter cube. Now you know that when the volume is 1 meter cube, the temperature is this. Okay, masa dia punya volume was 0.35, temperature dia berapa? 293.2. P was what was the value? 79 something. 76612. 76612. This was state 1. At state number 2, okay, dia berubah. Apa yang berubah? We found out that when the volume increased to 1 meter cube, the temperature also changed, right? The temperature also changed to 837.71 K. P is constant because this is a isobaric process. So here, when they are asking you find the internal energy of the gas when its volume is 1 meter cube, the temperature that you should use if you decide to use temperature in your equation should be this guy. Do not use the other one because you are already in state 2. Masa dekat state 2, volume dia 1. Tapi at the same time temperature dia pun dah lain. So when you are trying to find the internal energy, you should tallykan semula. V kena tally dengan T, kena tally dengan T. Because P is constant, so yang tu kita boleh abaikan. But what I'm trying to highlight here is do not use the temperature at state 1. Kalau V dia berubah and kita tahu T dia berubah, pakai semua value yang baru. Okay, so with that said, U equals to 3 over 2 nRT. So Farah used the new temperature and also this is the N is constant. So this is the final answer. So you can also write this as 3 over 2 PV where your answer will still be the same. Do I have my calculator? Let's try. So P is 7, harap ni betul lah, 76612, right? And our new volume is 1, okay, times 3 divided by 2. So my answer is okay, using this equation, I got 114918. 1, 2, 3, 4, 5. So this is 1.15 times 10 to the 5 joules. So sama, you can use PV or nRT. Make sure it's 3 over 2 or 5 over 2. If it's monatomic, 3 over 2. Kalau diatomic, 5 over 2. Okay, any questions about the first question? Wah, lamanya saya explain. Takutnya tak sempat ni. No questions? Everyone's okay? Good job, Sofara.
Okay.
Okay. Alright, moving on. Continue with F. F soalan dia. Compute the change in internal energy during the expansion. So it's asking what is delta U? Tadi tanya U. So U kena tahu kita tengah cakap pasal state 1 or state 2. Now it's asking the change in U. So the change in U, so we are talking about monatomic, right? 3 over 2 N R delta T or 3 over 2 P is constant, delta V. Okay, so here, Anis Nadira did it like this, U final minus U initial, because did we find this first state? Oh yeah, this is at state 1. And then when it expand, this is state 2. Okay, so Anis just use the answer terus. So state 2 minus state 1. So state 2 is 1.15. And then state 1 is 40221. So that is how Anis Nadira did it. U final, the U at state 2 minus U at state 1, or basically U final minus U initial lah. Okay, so here 1.5 times 10 to the 5. Oh, maybe soalan Anis Nadira lain daripada Sofara, so tak apa. And then 40221. Oh, patutnya macam sama je, 40221. Okay, sama. So it should be, I don't know, should be whatever the answer that is lah. And then ni senang je kan, delta U. So if you don't want to use this method, you can use the equation that I put over here. So let's try that one. Delta U equals to 3 over 2, N is 11, R is 8.314, and the change in temperature was the temperature that, ya Allah teruknya saya tulisan ni. Temperature was 837.71 minus 837, tak ingat dah, 83, I cannot remember, 837.71, 837.71. This is why I can't do bio. 837.71 minus the initial temperature. So initial temperature is 293.2. Okay, so 293.2. Okay, so should be the same answer. So I'm going to try it. Times 3 divided by 2 times 8.314 times with 837.71 minus 293.2. Okay, please be the same. So it's 74, let me write it down, 74696.42. So kalau nak ikut cara bentuk jawapan yang ni, 1, 2, 3, 4. So 7.47 times 10 to the 4 joules. Lebih kurang lah. Okay lah. Okay. So you can use this method, U final minus U initial. Find the U at state final, find the U at state initial, or you can use this equation. Delta U equals to 3 over 2 NR delta T or 3 over 2 P delta V. Jawapan dia akan sama, I'm sure. Okay, so that's the approach. So G, compute delta U minus W. So they compute the change in internal energy minus the work done. So disuruh pakai ni balik, tolak dengan work done yang kita cari tadi lah. So work done was equals to minus P delta V. So whatever that answer is, it should be negative. So minus with the minus is positive. So this is your final answer. Jalan kira betul. Okay, so if this was the answer, typically this would be 1 mark, 1 mark. Kalau equation dia macam pendek and senang, selalunya tak kasih markah kat equation, but in correct substitution kita akan kasih markah. So here the substitution was correct, 1 mark, final answer 1 mark, 2 over 2. Contoh is how I would grade it. Okay, so here H, the question is, must thermal energy, okay saya sebutlah, must thermal energy be transferred to gas during constant pressure expansion or be taken away? Maksudnya, does the gas absorb thermal energy or does it release thermal energy is what the question is saying. Should I write it down? I think I should. Okay, must thermal energy be transferred, I should have copied and pasted, tak apa, to the gas during constant P expansion or taken away. Okay, so constant P expansion refers to volume, which is what happened. The volume expanded even though the pressure was constant. So that is sebenarnya benda tu weird lah. It's not basically a normal occurrence. Kena ada energy yang diberi ataupun di-release. So this is what the question is asking. Because this is not a normal occurrence, selalunya bila expand volume, pressure menurun. But in this case, the volume expanded but the pressure was constant. So it's asking, is Q absorbed by the gas or is Q released by the gas? So that is the question here. The answer is, since the answer is positive, the delta U minus work done is positive. This is the, saya baca skema jawapan The increase in internal energy exceeds the energy transferred to the gas. Thus, an additional energy must be transferred to the gas by heat. Betul. So here jawapan dia, the increase in the internal energy exceeds the energy transferred by. Oh, korang ada solution tulis solution je ni. Okay, tak apa. So let me explain how this is. Okay, typically when we have a balloon and the balloon expands, dalam keadaan yang normal, you guys know when something punya volume expands, the pressure will decrease. So macam mana kita nak maintain constant pressure walaupun volume tu expand? Maksudnya dia kena ada additional amount of energy to keep the pressure at a constant level. Kita tak nak dia jatuh. Kalau jatuh maksudnya dia punya kinetic energy tu berkurang. So I want the pressure to be constant. So how do I make the pressure constant walaupun volume membesar? So in that case, I need to supply Q so that I can have the molecules bergerak dengan bebas dan keep at the same pressure. Remember, pressure ni adalah force over area. It's related to kinetic energy. So kalau saya tak nak kinetic energy saya berkurang walaupun volume membesar, I need to supply more. So I need to supply Q. Tak tahulah korang faham ke tak. So to supply Q untuk bagi P constant. So P pun happy. Saya dapat menjadi constant. Okay. Walaupun V membesar. So therefore more energy needs to be transferred to the gas. Okay. Any questions so far? Everyone okay? So is this explanation okay? Did you guys understood?
Yes, Doctor.
Okay, bagus. Thank God, because that was hard. Okay, I punya soalan, compute Q, the thermal energy transfer. So it's asking about Q, right? So we know that secara logik Q kita kena tambah because we want to keep the pressure constant. So we are assuming or kita predicting that Q should be a positive value, okay? So here, based on the first law of thermodynamics, you know that delta U is equal to Q plus W. So delta U minus W is equal to Q. And you have delta U, you have W. So here, sama je lah kan, sama dengan jawapan kat sini. Okay, so it's just Q. Okay, this is based on the first law equation, first law of thermodynamics equation. Wow, baru satu soalan, dah 20 minit. Okay, moving on. Okay, soalan nombor 2. Should I go to chapter 16 terus? I think I'm going to tackle one question from each chapter sebab saya takut tak sempat. Tapi nanti jawapan ni akan diberi kepada kelas. Soalan untuk chapter 16 is number 6. So this is, oh okay. Carnot efficiency nak discuss ke tak? This is number 4. Saya rasa senang, so I think I'll just leave it to you guys. This question number 6, question number 4, 5, 6, 7. Where's number 5? Siapa buat number 5? Orang tak jawab soalan ke? Siapa buat number 5? Tak jawab kat sini? Ke salah urutan?
Ada, tadi ada Doktor.
Ada 18. 18 tak ada. Yang 11. 11 ada, sorry. 18. Number 5. Siapa tu? Ngaku cepat. Nanti hantar balik Kalau siapa yang tak ada tu. Okay, number
5 ada.
Doktor nombor
Ada 5.
Kat bawah tu.
Oh, kat bawah. Yang kat bawah.
kesian Afika. Afika ke buat number 5?
Sorry Doctor, my Jimmy is having right now.
Apa? Lagi sekali? Tak dengar.
It is me, Afika.
Tapi kan saya rasa saya macam remove nama Afika daripada list. Ada lah nama Afika? Ada?
Ada.
Sorry. Sebab saya kan nak suruh Afika.
Tak boleh Doktor.
Okay. Sorry. My bad. Okay, moving on. So 5 is chapter 15. Kita akan buat chapter 16 dulu. Nanti kalau kita sempat kita akan go back to other chapters balik. Okay, number 6. Let's see. Soalan yang susah sikit. Number 6. Okay, number 6. 3 charges. Yang ni senang ke susah? Electrostatic force. Jangan. Nak cari soalan yang saya rasa akan cover banyak sikit benda. 9. Potential. Satu ulang. Hello? Aha. Tengah kelas. Kenapa? Okay. Alright. Bye. Plate. Tak nak. Sebab kita buat force lah. Okay, let's do electric force number 8. Sikitnya jawapan Danish ni. Rasa macam panjang je patutnya. Okay, so soalan nombor 8. So the diagram looks like this. Apa saya gigih sangat? Aku tadi copy paste je. Apalah. Wow. Macam ni. Lepas tu ada charge kat sini, ada charge kat sini, ada charge kat sini. This is P. And then kat sini 30 degrees. 30 degrees. Korang dengar tak siren tu?
Jangan Doktor.
Ada penjahat tengah kena kejar. Okay, 3 nanocoulomb. 3 bisingnya. Kejap. Lama pula tu. Hai, kat mana diorang ni? Lebih-lebih pula kan. This is R. This is R. Okay. So soalan ni cakap. Okay, tak apalah, saya kasih Chen. So 3-point charges are located on a circular arc. Okay, it's circular arc maksudnya, what does it mean? Circular arc maksudnya radius, a section that comes from a circle. So here, bentuk asalnya circle tapi dia ambil sebahagian je. So kat sini, bahagian ni je yang kita tengah tengok ni, nama dia circular arc. Okay. As shown in the figure below, let R be 4.2. I don't know what Danish punya R is. R dia 3.96. 3.96. Oh, this is hard. 3.96 centimeter ke? Okay, times 10 to the minus 2 meter. Okay, so that was Danish punya R. Assume that the x-axis is to the right and y-axis is up along the page. So x-axis is to the right, x-axis macam ni, positif, and positive y macam ni. Tu je dia cakap, up along the page. So dia nak suruh cakap, jangan pandai-pandai buat x to the left as positive. Dia cakap to the right is positive, up is positive y. Sebab kita tengah cakap pasal vectors, right? So kita kena define direction yang sepatutnya lah. And dia dah kasih siap-siap supaya korang tak mandai-mandai. Okay, what is the total electric field at P? So it's asking what is the E at P. So asking what is the E at P at the center of the arc. Okay, so to find out E, Danish buat macam ni. So E1 is equal to E2. Why? Why is E1 equal to E2? So E punya charge is 3, R is the same. Okay, so let's see what he did. KEQ, so KQ over R. Okay, E punya equation is KQ over R or F KQ over R F divided by Q. Kau tak silap. Betul tak? KQ over R. Rasa macam tu. KQ over R squared. Okay. F is KQQ over R squared. So E is the force per charge. So F over Q. So kita buang satu Q akan jadi E. Okay, so that is the equation that Danish used. So KQ over R squared. So E1 is equal to E2 because K is a constant. The charge punya value at here and at here is the same. And the equation is also over R squared. And the R is also the same, which is 3.96 times 10 to the minus 2 for Danish punya soalan. Okay. So here, this is what he said. EX is equal to 2KEQ over R squared times cosine 30. Okay, so this Danish dia cakap, okay, so there will be an X contribution towards this point. Okay, so for this type of question, what is the direction of E? What is the first thing that you need to do to solve these kind of questions? Do you guys still remember?
Letak test chart.
Letak test chart. Siapa yang jawab tu?
Mariam that test.
Mariam. Oh, Mariam. Okay. Thank you. Betul. Letak test charge. Small test charge. Test charge is always positive. Jangan sesekali letak negative test charge. Okay, and then after you put the test charge, you connect to the place that you want to find. Okay, and then remember your direction of electric field is also the same direction as your force because they are related because E is F over Q. So apa-apa direction F, that is the direction of E. So here the positive sign charge will be repelled, right? So it wants to go this way. And for this guy, it wants to go this way. Remember, the direction goes along the dotted lines. The dotted lines is connecting to the place that we are trying to find. Okay, and then this guy is negative, so it wants to go to this side. Okay, so this is the first part, dotted lines. Second part, third part, the arrows, right? The direction. I don't remember yang saya ajar step dia ada berapa semua, tapi this is how I remember it. Kalau saya salah, tolong betulkan. And then once you know the arrows, you can say, okay, the Y should be here, the X should be here, the Y should be down, right? Kalau saya buat saya punya axis macam ni, this is my X and this is my Y, salah. Because my arrow tak masuk dalam benda Allah ni pun. Dia tak masuk dalam this region. So it's wrong. So my Y is not correct. So for this guy, this is my X component and this is my Y component. Y component dia ke bawah. Tapi Y component untuk atas ni ke atas. Tapi magnitude dia sama sebab value dia sama. Remember, the equation only gives you the magnitude, the direction. You need to draw on the diagram. You need to find out on your own. Cannot use equation to find out the direction. So draw the arrow, find out how the Y and the X components are. Okay, in this case it's positive up, negative, and then X is negative, negative X, downward Y is negative Y. And for this guy, the Y component tak ada. Don't say X because it's going to be confusing. Y component is 0 and the X component is positive, right? It's positive X. This is the X component, sama. Okay, that is your X component. Okay, so that is the direction. And then now let's write the equation untuk untuk F. Untuk E macam mana? So I want to find out the electric field at point P. Let's see how Danish did it. Untuk EX, 2kq over r squared cosine 30 minus kq over r squared. Okay, let's see what that means. So kita ada 1 over here and 1 over here, so that's 2x. I believe this is what Danish is trying to say. And to resolve the arrow into the x component, it is also 30 degrees. So betul lah cosine 30 tu dipakai dengan betul. What about this guy? Okay, sama. This is also 30 degrees over here. Kalau tak nampak, saya besarkan. Okay, so 30 degrees over here, betul. I'm just following over here. 30 degrees over here, betul. I am just following this guy over here. Okay, so what Danish did was, he said F cosine 30. Sorry, E cosine 30. E cosine 30 for this guy. E cosine 30 for this guy. But it's negative. Sebab dia ke arah kiri. And then for this guy, it's E cosine 0 or just E. Cosine 0 means 1, right? So it's just E. So whatever the value of E over here, that is your x component. And cosine 0 is just 1. So tak payah darab dengan cosine 30 ke apa ke, it's just 1. Okay. So now my EX, so my EX punya component is minus E number 1. Let's label this number 1, number 2, and this number 3. So E1 cosine 30 plus E3 cosine 0. You don't have to put the cosine 0, you can just put E3, and then minus E2 cosine 30. Okay, so Danish dia shortcut lah sikit lah. Dia buat 2E cosine 30 sebab dia cakap E1 dengan E2 ni magnitude dia sama. So dia buat terus 2. Boleh juga. So E, macam nak cari? E is KQ over R squared minus, and then cosine 30. Our Q here, nanti kita akan substitute. Saya nak buat equation dulu. Plus KQ, this is number 1. This is KQ number 3. R squared. Cosine 0, let's just get rid of the cosine 0 terus. And then E2 is KQ2 over R squared cosine 30. Okay, so R is the same for everyone, right? R is this, the R over here is the same, the R over here is the same, the R over here is the same. This is the beauty of using something that is circular. All the radius is the same at anywhere. So if my point is here, the R is still R. Okay, dia tak berubah. So typically kalau soalan circle, that's the tricky part. You have to know that the radius is the same. Okay. So now kita akan substitute. So minus K, Q1 is 3 nanocoulomb over, what is R? 3.96 times 10 to the 2. Saya akan factor out je lah sebab semua ada R squared. Let's factor it out. 1 over 3.96 times 10 to the minus 2. Ni untuk X component je baru. Okay, so minus K, what is K? I don't know. K and then 3 nanocoulomb cosine 30 plus K. Factor out K jugalah kan? Sama je. Okay. Let's just use K. Because everyone has K and everyone has the same R squared, saya letak kat luar. Okay, so this is K and this is R squared. So Q1 is 3 nanocoulomb cosine, let's get rid of the coulomb first. Cosine 30, and then plus Q3 is 3 nanocoulomb. Sorry, it's not 3, it's minus 2. Okay, one thing to note here is when using this equation, the signs of the charge should not be put into the equation. Let's say it's -2, but it doesn't matter in the equation. Use 2 only because memang macam tu, memang equation dia bagi magnitude sahaja. This negative and the positive is given by your direction of the diagram that you draw, okay? Then this is positive 2 nanocoulomb, and then this is -3 nanocoulomb cosine 30. So let's just times it with a 2 if we are lazy. Or tak lazy pun tak apalah. Okay. 3 nanocoulomb, -3. So patutnya akan samalah dengan Danish punya X component minus Q. K over R squared, factor out, betul. 2Q cosine 30 minus Q. Here Danish did not define to the left as negative. Instead, to the left he said is a positive and to the right is a positive. Terbalik lah. So kalau saya nak kena betulkan yang ni, saya akan bagi markah kat sini. This is 1 mark. Substitution akan tak dapat markah. Sebab soalan dia specifically cakap to the right is positive and upward is positive for Y. So because Danish did not use that information in his answer, so untuk substitution punya markah tak dapat. Okay, walaupun jawapan dia betul, walaupun jawapan dia boleh jadi betul in the end. Okay, tapi untuk substitution punya marks tak dapat. Okay, and then K over R squared. It's okay Danish, we're learning here, so don't be shy ke apa. Biasalah tu buat salah. Okay, so 2 times 3 times 10 to the minus 9 cosine 30 minus 2 times 10 to the minus 9. Okay, betul. 1.893 times 10 to the 4 Newton per coulomb. Remember E is F over Q. So this is Newton, this is coulomb. So your SI unit is Newton per coulomb. Or if there is another version of electric field, I believe there is, tapi saya tak ingat apa. I think it's voltage meter kot, tak ingat. Okay, so jawapan ni magnitude dia betul. Kalau dalam skema jawapan dia specifically minta ada positif atau negatif, jawapan Danish ni mungkin dapat separuh je. Sebab ada unit, ada jawapan yang separuh betul. Yang sepatut-patutnya kena ada negative sign. Okay. So this would give him 1 mark kalau ada negative sign. Tapi kalau jalan kira dia towards the end, jawapan final dia betul, nanti boleh ada consideration jugalah. Nanti akan tengok lah. Tak adalah macam hati batu. Okay, so okay, that was X. So betul, apa Danish buat ni betul kecuali sign je yang tersilap sikit. Okay, and then EY, let's look at EY. So EY, orang kat sini ke atas, orang kat bawah ni ke bawah, and then this guy tak ada. So if they have the same magnitude, patutnya diorang cancel out lah. So did he say it's cancel out? Yes. So if this guy does not cancel out, this equation would be E1 sine 30 and it is a positive. Kenapa dia tak? Okay, sine 30 kat sini, sine 30, and this guy is equals to minus E1 sine 30. Remember E1 and E2 sine 30. So remember E1 and E2 punya value sama magnitude. So if they have the same magnitude and then the same sine 30 juga positif, seorang negatif, jadi dia kosong lah. So E1 sine 30 minus E2 sine 30 will give you a 0. So here he used the signs correctly. So akan dapat markah, betul. Okay, and then the final answer to finding the electric field is EX squared plus EY squared, square root the whole thing, put in your EX squared, then EY, and then you will get 1.83, kenapa ni? Ada 1.83 times 10 to the 4 Newton per coulomb to the right. To the right because why? To the right. Is it because our EX, so our EX is negative, our EY is kosong. So actually it's to the left. Let me see my jalan kiri jap, jalan kerja. Dapat to the right. Jawapan cakap to the right. Tapi saya rasa jawapan to the left.
The
Does anyone know why?
Yang EX tu saya dapat positif.
Apa dia? Lagi sekali.
Yang EX tu saya dapat positif.
Jawapan dia positif. Untuk EX positif. Walaupun kita buat this guy as negative and this guy as positive. Memang dapat. Oh, kejap sekira ya. 1 point. Okay, let's see, 18.99 times 10 to the 9 divided by 3.96 times 10 to the minus 2. Kenapa saya sibuk nak kira constant ni? Sekejap 2 times 3 times 10 to the minus 9. This guy is negative. This guy is negative times cosine 30. Your calculator should be in degrees mode. Okay, so and then plus 2 times 10 to the minus 9. So dapat negatif. Jadi kau dapat positif Did anyone get the to the right and know why? Boleh tak explain apa yang saya silap kat sini?
Betul. Okay, kalau ada negatif, dia sebab same charge, so dia akan jadi negatif lah kan. So dia akan repel ke kanan.
Dia akan repel ke kanan. Ke kanan. Kalau repel ke kanan. Kalau repel ke kiri lah. Sebab kita tengah cari dekat point P. Kenapa dia nak repel? Kejap. Okay. This guy is positive charge with a positive charge ke sini. This guy is ke sini. This guy is attracted. The summation of these two guys is negative. This guy is positive. But the EX is to the final answer saya dapat sini is negative tau. So the EX component final is this way. EY is 0. So E is EX squared plus 0 squared. So basically E is just EX, which is it's either to the right or to the left. But since my total EX is negative, it should be to the left. I need to check back on this one. Ada tak orang dapat positif for the EX? Tapi saya salah baca soalan. Okay, tak apalah, saya akan check back balik on the final answer, direction je. Magnitude semua betul. So Danish did it correctly except for the direction, I'm not sure. Jawapan dia to the right dalam web assign ni. I don't know why. Kat sini pun dapat okay. Saya silap. Saya dah tahu dah kat mana saya silap. Okay, guys. There is something, I did a grave error because saya pun tak revise lagi. Okay, first of all, when we are talking about a point P, right? When we are talking about point P, all the E's should be directed on this point. Here, saya buat point kat sini. Even though untuk force, contohnya soalan untuk force. New slide. Okay, soalan untuk force. Contohnya charge 1, charge 2, charge 3. So saya tanya, what is the force on charge number 3? So I need to draw all my arrows on this guy. Doesn't matter. So let's say it's attracted to this guy and it's repelled by charge 1. So all the arrows should be on charge 3. So sama juga, mistake saya kat sini is for the electric field, saya main letak arrow dekat charges. Patutnya saya letak charges kat sini. My arrows over at the point P. Okay, so that was my mistake. That is why our directions is not correct. Okay, so now if I were to draw my correct arrow, let's draw it. Okay, so now I have a positive test charge and a positive over here. I am going to be repelled, right? Repelled this way. Nah, tengok tak? Saya kat sini, saya tulis ke sini. So dia terbalik. Okay, and then I am a positive charge. This is a positive charge. I am going to be not attracted to this guy. So I'm going to be repelled. So it should be this way. And kalau tengok kat sini kan. So memang terbalik dengan apa yang saya buat tadi. And then here, I'm going to be attracted. So this is my E. So this is E for charge 3. This is the E from charge 2. And this is the E from charge, sorry, this is 1. Sorry, this is 2. Charge 2 and then this is the E from charge 1. Saya ambil pada dotted line juga Wow. Okay. Faham tak kenapa apa yang berlaku kat sini? What went wrong? Semua orang dah terus macam blur terus. Oh my god. Okay ke? Everyone's still okay? Don't die. Okay, so now remember kita kena letak arrows dekat tempat of interest. This is the grave mistake. And when I taught you this chapter, this is what I highlighted and I forgot it myself. So that was really bad of me. Okay, so E2, the X, let's use a different color. Okay, so this is my Y component, is a positive. This is my X component, is a positive. E2 punya component and then E1 punya component, let's use blue. This is my EX, this is my EY. And then for my E3, let's use gray. So E3 is just this. Oh, this satu je. Okay, thank God. Okay, so E3 is a negative X. E2X, E1X is positive. It's 1, 2. So dua-dua ni positif. So jawapan kat sini akan dapat positif. So betul lah Danish buat. Kesian dia kena tuduh dengan saya. Okay. So here he did it correctly. I am the one at fault. So betul. Get 1 marks. Excuse me. Okay, so magnitude wise everything was correct. The direction yang saya silap kat sini and you should be aware as well because I did this mistake and so jangan repeat my mistake, okay? You need to be aware how to draw this. Please draw. Okay, please draw. If you mess up in the calculation, at least when I look at your diagram, I can give you marks. Please draw. Okay, where should you draw it? At the point of interest or at the charge of interest. Let's say for soalan charge, force, dia tanya what is the charge on charge 3. Sorry, what is the force acting on charge 3? So charge 3 is where you draw your arrows. So kalau soalan tanya what is the force on charge 1, then you draw lah. So positive, negative and positive. So attracted, this guy is positive, so it's repelled. So this is force number 1. Force number 2, so you should draw at the point of interest. Okay, very very important. Okay, I'm very sorry sebab saya selalu macam tu kan, tersilap. Lepas tu macam kita belajar something that is very important that you shouldn't be doing in the test. Okay, moving on. So that was chapter 16. So soalan B untuk soalan tu is find the electric force that would be exerted on a 4.8 nanocoulomb charge placed at P. Oh, okay, so it's a force question now. So it's the same question, but now we are talking in terms of force. This one was electric field. Now let's talk about force. Okay, so same gambar. So senang je lah patutnya sebab kita dah tahu apa yang kita silap, apa yang tak patut dibuat. So here this is 3 nanocoulomb, 2 nanocoulomb minus, this is 3 nanocoulomb. R is the same, this is, dia cakap this is a 4.8 nanocoulomb charge. Dia letak charge baru. Tadi point P. point P kita cari electric field. Now kita tak boleh letak test charge, memang ada charge kat situ and they want to us to find out what is the force acting there. Okay, so let's apply what we have learned yang kita silap tadi. So this guy is a positive, this guy is a negative, positive, this guy is a negative. My charge of interest is the 4.8 nanocoulomb. So all my forces should be drawn over there. So this guy should be attracted. So along the dotted lines, that is my number 1, number 2, number 3. This is my force number 1. And then I will be repelled by the number charge number 3, F3. I will be attracted. So this is my force number 2. Okay, so I have my 3 forces on that charge. Now I want to resolve. So this is F1x, F1y. And this guy only has an x component. This is F2x, F2y. Okay. Kalau kita compare dengan electric field kita akan dapat tahu yang force dengan electric field arah dia sama. Okay, so look at this guy. I hope I'm right. Oh sorry, tadi test charge positif, so tak boleh, tak sama. Ni negatif. Kalau ni positive charge, akan samalah direction dia. Ni negative charge, so it's not the same. Okay. Alright, so now this is your diagram yang penting untuk dapatkan direction, and then for your force, the sum in the x direction for for charge number, let's call this P je lah. Okay, so x for 1 we have minus f1x, then minus f2x, and then we have positive f3. So f1 is minus kqq over r squared. The r should be the same, the k is the same. Tak apa, saya tulis dulu equation. So this is kqp, kq1 or 1p. Then minus kq2 qp r squared plus kq3 qp over r squared. Okay, so this equation, please put in the charges punya value. Tak ada positif, tak ada negatif. Nak tulis dia punya magnitude saja, dia punya value sahaja. This negative sign is from your diagram over here. If you don't have the diagram, most likely you will mess it up, or if you draw it incorrectly like I did before, you will mess it up as well. Okay, so here I can factor out the k, the qp, and the r squared. Okay, so this is now minus q1 minus q2 plus q3. Betul tak? Betul kot. Okay, and then k value dia apa? qp, the value is 4.8 times 10 to the minus 9. R is 3.96 times 10 to the minus 2. And then just substitute the value for Q lah. This is 3 nanocoulomb, and 2 nanocoulomb. Let's see what Danish did. Dia ke soalan B dia? Oh, Danish buat lagi senang. Okay, but let's go over the hard punya. So let's see if we get the same answer. Okay, so K, what is K? K is 8.99 times 10 to the 9. Let's see if we get the same answer as Danish. So 8.99 times 10 to the 9. And then this guy is 4.8 nanocoulomb times 10 to the minus 9. And then R is 3.9. Tak ingat dah. R is 3.96 times 10 to the 2. Okay, times 10 to the minus 2. And then this guy is minus 3 nanocoulomb, so times 2 just 6 nanocoulomb, 6 nano plus 2 nano. Okay, so I'm going to use my calculator. Hopefully our answer will be the same. So 6 minus 2, sorry, minus 6 plus 2 times 10 to the minus 9. Okay, times 4.82 kan? 4.8, oh 4.8 je. Times 4.8 times 10 to the 9 times 8.99 times 10 to the 9 divided by 3.96 times 10 to the minus 2. Ini baru X ni. So I got 4.4. This is 4X belum sampai jawapan akhir lagi. 0.36 times 10 to the minus 6. Betul ke? Minus positive. Okay, macam betul. Okay, I hope I use my calculator correctly. Okay, so for the Y components, we know that F1Y and F2Y will have the same value because they have the same magnitude dalam equation. Direction dia pula cancel out. So kat situ dah tahu kosong. Untuk this guy, the Fy is not there. So basically we are just looking at the X component, which is 4.36. I hope I'm right. Oh, salah juga. So here Danish, oh dia substitute dengan Q lain. So Q kita 4.2 times 10 to the minus 9. Kenapa 4.2? Oh, soalan saya 4.2. Is it? Sorry, 4.8. Okay, so kena darab dengan 5.03. 5.03. Let's see if we get it. 5.03. Sebab sometimes you cannot use this equation. You can only use this equation if you already found the E. But let's say the question asks you about force from the start. So this equation memang tak boleh pakai. So that is why I'm trying to go over the hard steps. You can use F equals to QE, no problem. Kalau E ada lah. Okay, so this guy kena tukar jadi 5.03. Okay, everything's so messy. So 9 times 10 to the 9 times 5. So this 9 cancels out. Yay. Okay, so now 8.99 times 5.03. Is everyone still with me or are you guys like sleeping already? I hope this is helpful. Takut korang rasa macam membuang masa ke. 1.14. Oh, lain pula jawapan dia. Oh, it's squared. This guy is squared. Divided by 3.96 times minus 2. So I got, takutnya. Okay, so this is 6 plus 2. Okay. 6 nanocoulomb, 2. Coulomb pula, nano. And I cancelled out this nano with this guy. And then I'm left with this and divided by minus 10 to the minus 4. Okay, 8.99 times 5.03 KQQ over R squared. Okay. Times with 4 minus 4 divided by 3.96 times 10 to the minus 2. Selembut. Sekejap. Okay, divided by 3.96 ke? Ke 100? Kan 3.96 betul. So dapat 1.14 times 4. Lain. So the answer is different. Q is to the right, the charge is negative 5 times. Okay, this one is to the left. Our answer should be the same. So Fx, F1x minus F1, this guy is negative, this guy is positive. So betul lah, attracted. F1x, F2x, F3 repel. F1x, F2x is minus, F3 is positive. K, Q, Q over R squared. K betul, Q is this guy, 4.8. No. Substitution betul ke? Silap, saya nak tukar ni jadi 5.03. The answer should be right. Why is it not right? 5.03 betul. 3.96 times 10 minus 2 squared betul. Factored out K, factored out QP. So I'm left with Q1, Q2 and Q3 minus Q1 minus Q2. Q1 and Q2 has the same value, so minus 6 nanocoulomb plus 2 nanocoulomb. I don't know what's going on, tapi tak dapat jawapan yang sama. Which kita sepatutnya dapat jawapan yang sama. Does anyone know where I did, where my mistake is? Times 5.03 times 10 to the minus 9 times minus 4. No one knows. Everyone is just as clueless as I am. Not. KQQ over R squared. I think we put values lain kot. 3 betul. Nano is 10 to the minus 9. R is we should get the same answer as Danish sepatutnya. Okay. Don't know what's going on. What is K? K punya value, K is 8.99 times 10 to the 9. Ini sama. K, Q, Q. Q dah dapat sini juga. So it's just this guy. Oh, okay. I know what went wrong. Okay guys, do you know what is wrong here? Kenapalah saya asyik buat salah hari ni? Do you guys know already? Not yet? Okay. So when we are talking about X component, kita kena resolve. Saya pakai as it is. Okay. Hey, hari ni cik salah je. 30. Cosine 30. Okay. So this is where it's wrong. So here 6 nanocoulomb cosine 30. Okay. So now let's try it. Hopefully betul lepas ni. 3 times 10 to the minus 9 times with minus, minus 6 times cosine 30 plus 2. Okay, 5.03 times minus 9. Korang pun blur. Bukan korang ke yang nak exam ni. Saya tak revise langsung tau. I'm telling you the truth. So 3.96 times 10 to the minus 2 squared. Saya dapat 9. Oh betul, dapat sama. Okay, so that was the wrong part. again, I did something wrong, which serves as a reminder to you guys that you should not do it. Okay. Force is Newton. Okay, so here what went wrong is I used the equation for force as it is, even though this was for x. X kena resolve. Use the cosine or the sine. Kalau y pakai sine. Okay. So this is the steps that you need to do and you need to show. Kena ada diagram, kena ada equation if they ask you about force. Tak semua soalan akan jadi indah macam ni, where you need to find the E and then terus cari F. Tak semua soalan macam tu, okay? So here Daniel simply use F equals to QE, which is the same as how I did it manually. Ni bukan manually lah, the long part lah, the long working steps, which is bound to have a lot of errors kalau kita tak berhati-hati macam saya tadi. Okay, so I'm really sorry again, I did a mistake. Okay, moving on. Okay, I think we should take a 7-minute break. If there is anyone who wants to ask me questions, you can, or just take your break for 7 minutes. Let's come back at 12:20. Okay, is everyone still okay, or you guys are like dying?
Dying.
Okay, dying. Tak apa, take the 7 minutes to revive. I'm also dying. Okay, so this was chapter 16. Chapter 17, kita nak buat soalan mana?
Kalau
Doktor,
apa dah miss. Doktor.
can I see your slide just now? Means that at the 10 slide.
Oh, okay.
Your work just now. Thank you, Doctor.
Okay, welcome.
Doctor,
Mm-hmm.
I have a few questions to ask. Can I ask now?
Ya, boleh.
Okay. Doctor, just now Doctor said that the equation will get 1 mark.
Mm-hmm.
Substitution, the correct substitution will get 1 mark, and then the last mark would be for the final answer and the unit together.
Yeah.
So for the substitution,
Mm-hmm.
it's like just now Doctor pointed out Danish method and said we must have the signs also. Like for an example, when we substitute for the F and E, we don't have to use the negative convention if it's a negative charge, right?
Tak payah.
So that one we no need to use, but if you want to find like the components, the x and y, then we need to add the negative positive, so there the negative and positive must be there.
Yes, betul. Correct.
Then
So if you use equation macam contohnya you just want to find F1 sahaja without resolving it yet. So F equals to KQQ over R squared. So jawapan dia tak ada positive or negative, tu betul. But when you use it to find the X components nanti, you need to have the signs.
that means in the substitution the signs are also considered, the directions, if it's necessary there.
If it's necessary.
Okay, Doctor. And Doctor, how many decimal points are actually good
Required?
enough?
Two.
Required. 2 decimal points.
Okay, I should put that in the notes as well. 2 decimal point. Kejap Umar, nanti saya letak balik dekat slide ni. 2 decimal points. Walaupun tulisan ni buruk, saya akan share yang ni. 2 decimal points.
Exactly 2 or can be more than 2?
Can be more than 2. 2 decimal points minimum.
Okay, Doctor. And another one is about the angles. I want to ask angles and direction, but I think that one we need to look at question number 6, the 6th diagram.
Number 6 diagram. Yeah. Question number 6 is okay.
For that one, I got the direction as mine is, and also Fateh's one is the same, 76.35 below the negative x axis. So can we answer like that in our exam, or we should consider the positive x-axis also.
Boleh jawapan below the your answer was below the negative x-axis?
Yes, doctor.
Boleh, but preferably refer to the positive x-axis. But jawapan tu tak salah lah.
Okay, doctor.
It's-
But in the web
acceptable.
assign, I don't understand why the answer they gave it in negative, and then they say it as counterclockwise from the positive x-axis. So I don't know why is it.
Oh, okay.
I
Nanti
don't
saya,
understand the statement, doctor.
okay. Sekejap saya tengok dulu Thanks Divya for the question.
Thank you, doctor.
You're welcome. Minus 101. Mana jawapannya? Number 6. Number 6. Oh, number 6 that you open. Okay, 3 charges. One charge Q 4.72 at the origin. This guy is repelled. This guy is attracted. Repelled and repelled. Sorry. So here is the angle. If we are going to find the the F, it's going to be here. Counterclockwise means this way from the positive x-axis. Counterclockwise. So this 180. A weird statement. 180 divided by 76. Jawapan nombor 6 apa tadi? Nombor 5. Nombor 6 is minus 104 counterclockwise from the x-axis. 75.73. Okay. $104 counterclockwise. Just clockwise from the positive x-axis. So if they are asking for counterclockwise, it should be this way. Should be this way. And positive x-axis is counterclockwise. 180 plus minus 101. Positive 259. Positive 259 jap. Stop sharing kejap eh. So let's see. Preview. Number 6. 260. Number 7. Positive 2, 3. Counterclockwise. Okay. Excuse me. Okay, what time is it? Oh, dah terlebih dah. Sorry. Google Chrome. Okay, is everyone back? I hope you guys are back. Let's continue with our mission. Your entire screen. Share. Share. Okay. Okay. Okay, now let's look at this question Divya asked me just now. Okay, so for question number 6, the answer is how should I show this? Let me copy this. Copy. So kita tengok jawapan dia cakap 107 counterclockwise from the x-axis. Let me just copy the whole thing lah. So now cancel. Okay, new slide. Insert picture from file. Okay, so this is the question. Alamak kecilnya. Okay, so this is the question. So this is a force question. So if I were to draw, the question is asking 3 charges are arranged, blah, blah, blah. Find the magnitude and direction of the force. Hello. Why are you not working? Okay, of the force on the charge of Q equals to 5.06 at the origin. So here we have a graph. Origin selalunya dekat tempat yang kosong lah. Origin memang start dari kosong. So this is the charge that they are talking about, the positive charge at the center over here. So this guy, so it's a positive. Let R12, okay, radius R12, the distance from the charge 1 to charge number 2 is 0.255. Okay, so the values don't really matter here. What I want to talk about is the direction. So if I were to draw the diagram, right, I want to draw all my forces on this particular charge, on the charge at the origin, because that is what the question is asking. So if this guy interacts with this guy, it will be repelled. So the force should start at the charge of interest, which is this Q. Not this Q. I can draw it like this. Boleh. Betul. Tapi soalan minta pasal this guy. So untuk menjawab soalan, letak arrows kita dekat charge ni lah. So this is the first one. Let's say this is charge number 2. This is charge number 3. This is our force due to charge number 2 and attract by charge number 3. Charge number 3. So here we have F2 and F3. So if I were to predict what is my resultant force, right? My resultant force, it would be basically between these two guys. If this is my resultant force. Remember, if I have a force and I want to resolve it, it is like this, Fx, Fy. Fy plus Fx gives me F. Fx plus Fy give me F. Basically, F is the resultant and I resolve it into the X and Y components. Kat sini, when I have something in the X, something in the Y, when I add them together, I will have a resultant between the X and Y. Kena between. Kalau X sebelah sini, Y sebelah sini, takkan F resultant sebelah hujung dunia sana kan? It needs to be between the X and the Y. So in this case, we have the X as our F2, the Y as our F3. I hope I'm making sense to you. Dia terbalik daripada sini je. Kalau kita ada satu F1 kat sini and I want to resolve it, this is how I will resolve it. If ada angle, then ada angle lah. So Fx is F1 cosine theta. This is F1 sine theta. Okay, and in this case we have F2 and F3. So the resultant force should be between here. Okay, so F is F2 squared, because this is my X component, plus F3 squared. This is the magnitude. This will give me the magnitude of my F. Whereas for the direction of my F, it is given by tangent theta equals to Fy component, Fx component. In this case, our Fy is down there, F3 minus, and our F2 is minus as well. So F2 comes positive, and then theta is just the inverse tangent of F3 over F2. Ada silap tak kat sini? Fy over Fx. Betul. So this is the direction, and this is the angle that you will get to find the direction of your resultant force. Okay, so now that you know how to find the theta, I'm not going to go over it. I hope you know this already. So theta akan diberi with respect to the x-axis, positive. Sorry, x-axis. Kejap. Kalau kita cakap pasal Fy, Fx, selalunya dia akan respect to x-axis lah. So in this case, kita tengok jawapan Fatihah tadi jap. Soalan nombor 6. So Fatihah dapat F13 is 1.36, F12 3.46. This is F12, this is F13. So dapat Fn, which is the resultant over here. Okay. So F12 should be the denominator. Okay, betul. 1.36 over 3.46. So she got 75.73. This answer is with respect to x-axis. It is always with respect to x-axis. Always. Always with respect to x-axis. Now, with that said, jawapan dia 75.73 with respect to the x-axis. But what I got over here is I got my F over here, right? This is my F. Sama dengan Fatihah juga. My F is down here, which means that the theta is not over here. The theta is over here. It will give you because your cara you kira the theta was using values from F2 and F13, right? So it should be between these two guys juga lah. Kalau dapat jawapan theta tapi it's over here, you said it's over here, but F12 is not over here. So how is the theta over here, right? So the theta should be dalam region of your forces. Now, jawapan dia dapat counterclockwise from the positive x-axis. It's asking you to find from counterclockwise from the x-axis. This is a requirement in the answer. So dia cakap, hey, find me the answer, but it needs to be counterclockwise from the positive x-axis. We have this answer. So in this case, the answer is, I don't know, 180. Kalau ikut soalan ni lah, minus 107 akan dapat 73. This is my 73. Okay, so it's asking, hey, give me the counterclockwise from the positive x-axis. So this is my positive x-axis. Counterclockwise is this way, terbalik dari arah jam. So I should be getting 180 plus 73. 180 plus 73 is 253. So 180 plus 73 is 253. Okay, so this one, I put it into the answer box, it is correct. But you can also answer it the other way. With that said, it means that 360 minus 253 will give you 107. But the answer should include a negative sebab dia terbalik. Faham tak? Okay, so from the positive x-axis, 180 from here to here, and then tambah 73, I will get from here to here. So this is 253, counterclockwise from the positive x-axis. But you can also answer it, how do I say this? You can also answer the complement of the 253. You can answer the complement of the 253. What is the complement of 253? It is 107, but you need to include the negative sign. Okay, is that okay? I think that is confusing, but untuk exam nanti, okay, requirement ni tak ada. Requirement, I am sure it's not going to be there. So what you should do is give me your answer with respect to the x-axis. So kalau Divya cakap 73 from the negative x-axis, yes, it's correct. Or if you want to say, what is this? 107 from the positive x-axis. Boleh. Boleh juga. Okay, just make sure the direction is correct lah. Janganlah main bantai je letak nombor apa-apa kan. Okay, you should understand what you're doing. Okay, kalau rasa benda ni confusing, please try to discuss with your friends. Please ask them to teach you. Jangan malu Memang kadang-kadang kita belajar lagi banyak dengan kawan, kadang-kadang kita belajar lagi banyak dengan guru. It doesn't matter how you learn as long as you understand. Okay? Alright, so moving on. Divya, was that okay?
Okay, doctor. Thank you, doctor.
Okay. So jawapan 253 or minus 107 is both acceptable. Okay.
The negative x-axis also acceptable,
Yeah.
right, doctor?
But for exam, just say with respect to x-axis, just give me the easiest answer lah. Okay.
Oh, okay,
Supaya
doctor.
nak cari complement whatever tu lah. Sebab 107 ni dah jadi complicated nak kena kira. Okay. Let's go on to chapter 17. Oh my god, we have 30 minutes to go. Chapter 17, soalan yang saya nak cover in class is chapter 17, soalan 11 sampai 15. Let's do number 14. Is it 14? Is it hard enough? Equivalent capacitance senang. 14, 15. Sekejap. Rasa capacitance senang lah. Patutnya korang boleh score. InsyaAllah. I want to look at question yang ada kena cari charges. Find the equivalent capacitance. If potential is 60, what is the charge stored on C3? Okay, let's do that one. Number 11. Okay, number 11. Kena cepat sikit. Number 11. What is this? 13. 11. Azmina. Siap ada bunga lagi. Comel. Okay, so let's do question 11. Question 11 says, consider the following figure. Okay, I am considering. Find the equivalent capacitance between point A and B. Okay, so point A is up there. Point B is down there. So A and B. This is A, this is B. Why am I using yellow? Let's use blue. Okay. Find the equivalent capacitance as shown in the figure if C1 I think my values are not the same. Okay, tak apa. Kita akan buat dulu equivalent capacitance. So here, remember the trick for series or parallel? For series, connected in by the same wire or same line, same branch line wire. Okay. If it is parallel, it needs to be connected by the same two dots. Okay, so let's see. C1 and C2. This guy is C2. C1. Ada macam tak nampak sangat kat sini. C1, C2, C3. Okay, so tak nampak. Might be me. C1, C2, C3, C1, C2. Okay, so C1 and C2 are they connected by the same two dots? So if I put dot 1, dot 1, dot 2 over here, is C2 connected by dot 1 and dot 2? The answer is no. So dia bukan parallel. Are they connected by the same line or same branch? If I flow I through here, adakah C1 akan jumpa dengan I as well? The answer is yes. So they are in series. So C1 is in series with C2. Okay, C1 is in series and C2 series. C1 and C2 series for both sides. And then C3 is up here. So if I say this is dot 1, this is dot 2. So dot 1 meets this over here and dot 2 meets over here. So if I add C1 and C2 together in series, I can say C12 is in parallel with C3 because C12 is connected by the same dots connecting to C3. Okay, so C12 is the equivalence for over here, looking like a peanut over here. So C12 is in parallel with C3. Okay, so this another peanut over here, C12. Okay, C12 parallel dengan C3. So C12 1 over C3, 1 over C12. So this should give me the equivalent for this big peanut. It's not a peanut anymore, but it's big. So this is my C equivalent for that part. C equivalent number 1. Okay, this guy is in series. So let me use a different color for series lah to help you nampak dengan lebih jelas. So this is series. This guy all together parallel. Parallel is in pink. Okay. Now we found the C equivalent for the top part, and then for the bottom part, C2 and C2. Both are C2. This is C2 and this is C2. So let's try to see if they are in parallel. So I am putting dot 1 and dot 2 over here. Is the other C2 connected by the same dots? The answer is yes. They are connected by the same dot. So I can say that they are in parallel. Okay, bersama. Ini adalah dot yang sama. Okay, so C2 and C2 are in parallel. Over C2 plus 1 over C. Sorry, parallel tambah je kan. This is series. Kenapa korang tak betulkan saya? Korang pun tak ingat ke? C12 plus C3 plus C12. C equivalent number 1. Kalau series untuk capacitance yang terbalik. C2 plus C2. C equivalent number 2. So this is your C equivalent number 2. Okay. Your C12 is 1 over C1 plus 1 over C2. So this is for series. This is for parallel. Dia terbalik dengan resistance. Okay, take note of that. So tak sibuk ni. So C1, C2, CS 1 over C1 plus 1 over C2, betul. Okay, C3 is in parallel, CP1. What is CP1? CP1 is CS, C3, CS. Okay, betul. CP2, C2 and C2, betul. Okay. So if you understood how to get this part, your answer should be correct. Let's see what Azmina did. C1 and C2 are in series. Yay, betul. C1, C2 and C2 are in parallel for the second part. Sorry, dia buat ke arah ke kanan. So in parallel 3.61 plus 6. 3.6. Okay, betul. Kalau dia kira calculator betul-betul lah. Saya tak kira sebab jawab saya punya values different. And then for the second part of the diagram, which is down here, this guy is in parallel, so tambah je terus. So basically C2 plus C2 is in parallel, so 13 plus 13. So you get 26 micro. Okay, so Azmina says star plus flower, star plus flower. Star plus flower, they are in series, so C equivalent 1, C equivalent 2 are in series. If I flow I, the I will meet C equivalent 2 without breaking. It will meet the same I. So here we can conclude that this is in series, so 1 over 26 plus 1 over 13.22 micron. So this is your C equivalent for the entire circuit. Okay, correct. So this was pretty easy lah in my opinion. Okay, number B. If the potential between points A and points B is 60, what is the charge stored on C3? So here it's saying from A to B. Where is our A and where is our B? I forgot. A ke atas, B ke bawah. This is A, this is B. The whole from A to B is 60 volts. Okay, so the whole circuit is 60 volts from A to B. So here I can say, kat tempat yang sangat kecil Azmina lukis ni, here to here is 60 volt. So my 60 volt should be divided between this guy and this guy. Okay. Okay, so how did Azmina did it? Let's see. Azmina cakap V equals to 60. C star is 13.22. C flower is 26. So using equation V equals to Q over C, or C equals to Q over V, then Q over V. V equals to Q over C, Q equals to CV. So C is 8.76. Where did Azmina get the 8.76 times 60? 8.76 is dari mana? Oh, it's over here. Oh, the C equivalent, sorry. The total. C total lah, kita panggil C total. Okay, so Azmina cakap C equivalent ataupun C total for the whole circuit is 8.76. Sorry resolution is bad here. Okay, so 8.76 micron times with 60. So basically what is Azmina doing? She's saying, okay, so if A to B is 60 and C total is 8.76, what is the total number of charges? So that is Azmina's approach. So what is the total number of charges along this circuit? So 8.76 times 60, you will get the total Q. This is not the Q for each capacitor, this is the total Q for all capacitors combined. Okay, so now step number 2. Let's find V star. What is V star? V star is, I don't know, Azmina said V star is the circuit on the top here. Kan ada circuit ni ada dua kan? Satu kat atas, satu kat bawah. So Azmina said, let's find the V for the top part. Okay. So V for the top part is Q over the C equivalent number 1. C equivalent number 1 was C star. What was C star? 13.22 microfarad. So if she divides V with, if she times, the Q total, right? The Q total is the same for the entire circuit, right? Because Q is related to I. So I will flow through both C equivalents 1 and C equivalent 2. They will have the same I, or they will have the same Q, right? So kat sini Q dia sama sebab they are in series. So what Azmina did is use the same Q, which is Q total, divided by C equivalent 1 to find out what is the V for the top part of the equation, which is this portion lah, this portion of the circuit. Kat sini. This is our C equivalent 1, V equivalent number 1, and for V equivalent number 2. Okay, and this was related to C equivalent number 1, C equivalent number 2. And our I that is flowing is basically just Q, that is Q total. They are in series, so they should have the same Q. However, when kita masuk dalam circuit, dia akan berpecah. So that is where we have the different charges. But kalau kita cakap pasal C equivalent 1 and C equivalent 2, they are in series, so they should have the same Q. Okay, this is the concept here. Okay, moving on. So we are trying to find V star, or the V for equivalent number 1. So V divided by Q total over C equivalent number 1. So 525, which we got from here, divided by 13.22. So this was, I think this was in micron, this was in micron as well. So boleh cancel out lah. Okay, so in this case, I would give 1 mark for equation and 1 mark for substitution. Walaupun Azmina tak letak micron. So micron tu akan cancel out. So mathematically this is still correct substitution lah. Okay. So 39.76 is her answer if I'm seeing this correctly. Okay. So this is also correct. So equation, substitution, and final answer with units. That is how you should answer always. Okay, so that is the V for the top part. Question dia apa sebenarnya? Question number 11 is asking you charge stored on C3. C3 is, okay. Now the question is, kita dah tahu what is the V from here to here. We know the V equivalent number 1. The question is asking, what is the V at C3? Remember, everything that is in parallel will have the same voltage. If this guy is 10 volt, this guy will be 10 volt. This guy will be 10 volt. Here to here will be 10 volt. So the answer is already giving us the voltage for C3. So this is the voltage for C3, and now it's asking find the charge stored at C3. We have the capacitance value, we have the voltage, now we can find the Q. So Q equals to CV, C3, and C equivalent number 1. So this is 6, I think this is 6, and then this is from here, over here. Oh, it's 9, it's not a 7. Kat sini nampak just 7, tak apalah. Apa-apalah asalkan equation dia betul jangan kira penting kat sini. So CV, C3 times the V equivalent number 1 will give you the answer, which is the charge at capacitor number 3. Okay. So remember, Q untuk series sama and V untuk parallel sama. This is the highlight for this chapter. Knowing that part. Okay. And then discharge and charging of capacitor, I think you can deal with that yourself. It's just math and also graph. Please revise back apa yang saya dah ajar dalam kelas, should be okay. Okay, moving on to the last chapter, which is chapter 18. Mana yang susah sikit? Sekejap Any questions so far from you guys? Oh my god, tinggal lagi 8 minit je tak sempat ni. Let's use this short one then. Okay, let's do number 21. I hope it's short. Lemak ni ada substitution. Tak apalah, I'll use the last 8 minutes to answer any questions that is bugging you when you did the web assign. Any questions? I will give the answers given by your friends to your WhatsApp group. You can go over it. You need to try it yourself. Compare your answer with the working steps of your friends. And if you still don't understand, you can ask me. Boleh boleh tanya kat WhatsApp je. Any questions? No questions? Saya tak sempat nak go over everything. No questions. Everyone's like tired already.
Assalamualaikum Doktor.
Saya nak makan.
Can you hear me?
Yes. Siapa tu Saya tak nampak.
This is Fakri.
Okay, Fakri, yes.
Internet is not good.
Okay.
I have 2 questions. The first question is, during the test, the paper is provided, right?
The paper is provided.
So we don't need to bring any extra papers from outside.
No.
Secondly is, dia kan dari web assign, then the pages setup is literally like web assigns or
Tak. Korang tak pernah jawab soalan face to face last semester?
Never.
Oh. Tak sama macam web assign. Web assign ni macam setup dia macam mana? So the setup is from my memory lah. It's question, figure, and then baru soalan yang the first one will describe the figure and then they will give you a diagram of the figure and then they will ask you, okay, explain or define or please calculate, macam tu. Tapi bukan macam web assign lah. Web assign.
Oh, okay. Is it the mark is allocated too, Doctor?
Macam mana lagi sekali?
The marks. We know the mark.
Dia tulis marks kat sebelah tu.
Oh, okay. Okay, that's all for me. Thank you.
For your test, I prefer you use a pen, but you may use pencil. I'm okay with that. Okay, boleh pakai pencil juga. What else? You may use your calculator. You may bring your calculator. Please bring your IC or your metric card. I don't think you have metric cards anymore. Tu je lah yang kena bawa, pembaris, pemadam. Bawa je. Okay. Or if you're using a pen, bring your liquid paper or your correction tape. Please do that. Okay, saya kasih awak pakai pencil if that is comfortable, if that is going to help you. Okay, tapi memang tak dapat tukar jawapan lah. Itu je lah nak cakap. Walaupun pencil, once you submit it, I'm not going to let you guys touch it. Faham tak? So that is the cons of using pencil. Once I get the paper, you will not be able to take it or you will not be able to touch it anymore. Because if you touch it, you might change the answer. Walaupun saya tahu korang tak macam tu. But I cannot allow that possibility to be there. Okay? Saya kena jaga jugalah saya punya ethics. Okay? So if you are using pencil, memang you have no chance of touching your paper ever again. Saya akan bakar. Tak adalah saya tak bakar pun. But I will keep it away from you lah. Okay, so all the best. Tomorrow, I will not be conducting class, but I have something recorded. If you feel like you need that extra 1 hour to do your revision, please do so. But you need to promise me that you will watch my video when you are free later. Kena wajib lah sebab saya tak akan ulang dah that chapter. Chapter 19 part 1. Tomorrow is chapter 19 part 1. If you want to do revision during that time, I allow you. But you must promise me that you will watch the video afterwards lah, lepas habis exam ke, tak kisahlah, asalkan tengok sebelum the next class. Okay, is that okay with everyone?
Yes, doctor.
Yes, doctor.
It's going to be recorded lecture tomorrow. Other than that, you're not going to see me until the test. So if you have any questions, you can WhatsApp me personally or in the group. All the best. I will be praying for you. Jangan nervous. Just remember what we have learned in class. Remember equation, correct substitution, final answer with units. Please keep that in mind. Okay? So I believe you can do it. Okay, bye guys. Good tu.
Thank you, doctor.
Thank you, doctor.
Thank you, doctor.
Thank you, doctor.
Thank you,
Thank
doctor.
you, doctor.
Welcome.
Thank you, doctor.
Thank you, doctor.
Thank you, doctor. You're welcome.
Doctor,
Yes.
for my attendance, do you have change it, doctor?
Belum. Saya buat lepas ni.
Okay, thank you, doctor.
You're welcome.
Doctor, I have a question. If during the exam we need an extra paper, could we just ask for it?
Boleh.
Okay, thank you, doctor.
You're
Doctor,
welcome.
kan kalau bahagian equation, kalau kita letak, kita akan dapat markah. So macam, tapi macam kalau macam saya tak confident dengan equation tu and saya letak 2 equation, macam, and salah satu equation tu betul, akan dapat markah ke tak?
Boleh cuba, tapi nanti kiranya cara kerja awak memang hentam lah. Awak takkan pilih. Saya akan
kalau
pakai
dua-dua
equation
juga?
yang awak pakai. Sebab nanti kena pakai equation tu kan. Kalau soalan definition, bolehlah nak letak dua-dua kan. Lepas tu nanti saya pangkah lah mana yang awak salah. But if the question suruh calculate and you give me 2 equations but you choose only one, I will take the equation that you used.
Kalau saya buat dua-dua, kira doktor akan tengok dua-dua lah ke macam mana?
Saya akan tengok dua-dua. Kalau dua-dua salah tak dapat lah.
Okay, tak faham.
Okay?
Thank you, doktor.
Alright. Okay, bye guys.
Bye, doctor.
Bye.
Bye, doctor.
Guys, take care. Anything, just ask me.
Bye, doctor.
Bye. Sleep.
Record lagi ni.
Itulah keluar guys. Masih record guys.